Hi, this is Andreas. This is my screencast for the air rocket activity. Um, Here is my the times I got for the air rockets, the data. For the low, I got 3.42 seconds. For the medium, I got 3.96 seconds. For the high, I got 5.48 seconds, and for the super high, I got 5.59 seconds. So the first question asks to sketch a diagram of the situation and use arrows to represent the position and velocity of the rockets at 0 seconds. So here is my diagram of it. So the rocket starts at 0 meters, goes up at an initial velocity, reaches its highest point, then goes back down at the final velocity and back to 0 meters. On to number two. It asks to sketch a velocity time graph and acceleration time graph. uh, the velocity time graph, it basically starts at the initial velocity, and this point right here is where it reaches its highest point and reaches a velocity of 0. So, and when it goes from a positive to a negative, it's changing direction and then goes down to its final velocity at whatever the time would be here. For the acceleration graph, it's a constant acceleration at negative 10 meters per second because that is the acceleration of gravity, and whatever time we choose. So for the we put the time for the low there, or medium, or the high. Um, Number three is asking what is the change in velocity of the rocket, and to explain how you figure this out. Change in velocity is, you can basically find it by finding the displacement of the acceleration graph. So it would be the acceleration times the time, and that's basically the area of this graph. So for low, it would be negative 10 times 3.42, and that would get you negative 3.42 meters a second. For the medium, it would be negative 10 times 3.96, and that would give you negative 39.6 meters a second. Uh, for the high, it'd be negative 10 times 5.48, and that will get you negative 54.8 meters a second. For the super, same thing, and we'll end up getting negative 55.9 meters a second. Number four asks, how fast was the rocket traveling when it was launched, and how do you know? So, for this one, it's basically the initial velocity is the equal to the final velocity. So if you wanted to find out the speed of the rocket when it was launched, you're finding initial velocity basically. So it's the change in velocity divided by 2. So the change in velocity is you get that from the previous questions, and so for the low would be 34.2 divided by 2. So it's what do you call it? Its speed is 17.1 meters a second. Oh, and since it's speed, there's no such thing as negative speed, so it's going to be positive now. Medium, you put in the numbers, you 39.6 divided by 2, 19.8 meters a second. For high, 54.8 divided by 2, its speed would be 27.4 meters a second. The super high, 55.9 divided by 2, and then you'll get 27.95 meters a second. So yeah, that's how you find the how fast they were going when they launched, their initial velocity. Um, Number five is asking, is the speed when the rocket was launched different from the speed just before the rocket hit the ground? And explain your logic. Um, Basically, you can read this off. No, the speeds are the same because the rocket has a constant acceleration. So, however long it takes the rocket to accelerate as it slows down going up, uh, it is equal to the time it takes for the rocket to speed up going down. So it's the initial speed is equal to the final speed. Initial velocity is equal to final velocity, basically. Um, On to number 6. Number 6 asks, what was the maximum height of the rocket? How did you figure this out? So, when you're looking for the maximum height of the rocket, it's the rocket's trajectory. The position time graph would look like this downwards opening parabola. So its maximum height would be up here. So what you're looking for is the displacement at half the time and at initial velocity, half the time at initial velocity. So it would be 1/2 times, for the low, 1/2 times 17.1 meters a second times half of 3.42 seconds. So what you'll end up getting with that is 14.62 meters. Basically it's the same thing for all the others. Medium, you'll put in the initial velocity there and the time it took for it to go up and down there and divide that by 2. It's all the same. You plug it in, you'll get for medium 19.602 meters. For high, you do the same steps, you get 37.55 meters. Super, it's the same thing, 39.05 meters. On to number 7. Number 7 asks, was the acceleration different when the rocket reached a maximum height? Explain your reasoning. Number 7, oh, okay, that's weird. Okay. The acceleration would not be different because it's the constant acceleration of gravity at 10 meters per second per second. So it's the acceleration of gravity. It's always affecting any free falling object. It's constant. Number 8. What was the total distance that the rocket traveled? How did you figure this out? The total distance the rocket traveled is equal to 2 times the displacement at the highest point. So it's the displacement is change in position. So change in position when it reaches its highest point was that number. So for low it was 14.62. So we multiply that times 2. So 14.62 times 2 is equal to 29.41 meters. So that is the total distance the low rocket traveled. For the medium, it's the same thing. You plug in 19.62 times 2 and you get 39.204 meters. High, same thing again, 37.55 meters times 2, 75.1 meters is the total distance that one traveled. The super high is 39.05 meters times 2, so you put those together, you'll end up getting 78.1 meters. Number 9. What was the total displacement of the rocket? How did you figure this out? So number 9, I can finally put them all in one. The total displacement of all the rockets is 0. Like I said previously, displacement is equal to change in position. Position. So since the rockets started at position 0 and went up, back down, and ended at position 0, there is no change in position. They start where they stopped, and well, they stopped where they started. And finally, number 10, are your answers different for the last 2 questions? Why? Yeah, they're different. The number 8's asking for distance traveled, and number 9's for displacement. Displacement does not mean distance traveled. In some scenarios, displacement can equal distance traveled, but it does not mean distance traveled. Displacement is, like I said, change in position or velocity or whatever. It's the change in something. Distance traveled is the total distance the rocket traveled. So if it started at 0 meters and ended at 0 meters, went up, back down, ended at 0 meters, its displacement is 0 meters. But the distance traveled is, let's say the highest point is 2, so it goes up 2 meters and then back down 2 meters. So its total distance traveled is 4 in that scenario. Um, so yeah, that's it. That's my explanation for the air rocket activity.